What's up YouTube, this is Demkeys back again with another Unity tutorial, and today I'm going to teach you about navigation. Unity's navigation system allows you to add pathfinding abilities to your characters. For example, if you wanted your enemy character to avoid hitting walls or other objects in its way, you would probably have to write a lot of code for it, validations for collision and all. But using NavMeshes, you can program the character to automatically avoid obstacles along the way. I'm going to demonstrate this example now. What we have in the scene is a plane, a few objects that we are going to use as obstacles, and an enemy character. The enemy character has a camera attached to it. Of course, we have these lights as well. What next? Yeah, now in order to make our plane ready for navigation, we have to create a nav mesh for it. The act of creating a nav mesh is called baking. Let's set up a nav mesh for the plane. The first thing you need to do is bring up the navigation window. To do this, click Window, Navigation. My window is already opened up over here, so for you it's going to show up once you click Window, Navigation. In the navigation view, we have three tabs: Object, Bake, and Layers. We will go through these one by one. Now, before you bake a nav mesh, you first need to choose which objects are going to be navigation static. Navigation static objects are objects that won't be moving at all. Setting objects as navigation static helps Unity calculate the path accurately so that your character can go around the object rather than just collide with it. Some examples of navigation static objects would be floors, walls, and other static obstacles. You can set an object to navigation static by clicking the object and checking the navigation static checkbox in the navigation view. So in this case, we would want to set all these objects, all these objects being these cubes and the plane, to navigation static. So what I'm going to do is first select all of these objects and then check navigation static. Back to the Object tab. Off-mesh links generation can be checked if you want to generate off-mesh links. You would use off-mesh links in cases where you want the character to jump from one nav mesh to another. I cannot show you an example for off-mesh links because Unity's basic version doesn't support it. Sorry about that. Next, we have navigation layers. We'll talk about that a little later. Now, in cases where you have a lot of objects in the scene, you might want to filter certain objects out. You have three types of filters. All, which is this one, which shows all the objects present in the scene. Mesh renderers, which shows all the objects in the scene that have mesh renderers attached to them. That is these objects. And then you have terrains, which in my case isn't showing anything because I don't have a terrain on the scene. Terrains, when you select the terrains filter, it shows you only the terrains on the scene. Next, let's look at the Layers tab. In the Layers tab, you can create and edit navigation layers. Apart from the built-in layers, you can also create user-defined layers. You can set costs in these layers, and those costs will affect the calculations made during navigation. Like, for example, if you create a layer and apply a high cost to it and assign that layer to one of the planes, it will be harder for the character to walk on that layer or on that plane, and so the character may not take that path in the first place. Instead, it might choose some other way. We are not going to go into much detail with that in this tutorial, but feel free to experiment on your own. Next, the Bake tab. The Bake tab helps you set properties for NavMesh baking. Radius determines how close our character can get to walls and other static objects. Height determines how high the ceiling must be for our character to walk below it, or to be able to walk below it. For example, the path may be clear, but the ceiling may not be high enough for our character to pass through, and so he's not going to go under it. Max slope determines how steep a slope can be before it is considered a wall. Step height determines how high a step can be before it actually starts to block a character. For example, something like this. We wouldn't want the character to step over something that's this high. Of course, we can change the value here and then give the character the capability to actually use that as a step and walk over it. I won't be explaining off-mesh generated links because, as you can see, this is only available in the Pro version of Unity. Advanced properties work just fine. This is advanced properties. Advanced properties they work just fine with their default values, but you can change them if you'd like. Sometimes you might want to customize it to your own needs. Alright, min region area. It specifies how much minimum surface area a surface must have uh, for it to be included in the nav mesh. Width and height inaccuracy dictate how accurate or inaccurate the mesh will be around the edges. You can also choose to have a height mesh created. This will improve the accuracy but will make generation much slower. Once you are done with all the settings, click bake. Just a minute. Let me select all these. You have to select them. I think you have to select them. I'm not sure. But I'm gonna select them. And I'm also gonna check height mesh. Let me just check that once more. Okay. This is how you bake a nav mesh. The next thing we need to do is add a NavMesh agent to our character. The NavMesh agent component is used in connection with pathfinding and is the place to put information about how this agent navigates the NavMesh. To add a NavMesh agent to the character, select the character, click Add Component, Navigation, and NavMesh agent. Alright, so the NavMesh agent has a couple of properties over here. I'm not going to explain all of them because I cannot explain them very well. I'll just explain some of them. Radius. Radius will be the agent's radius. This is not to be confused with the radius of the collider. The collider's radius is different and the agent's radius is different. The agent's radius will be used for calculations. Then speed. Speed is the maximum speed that our character can use in order to get to its destination. Acceleration is how fast it will get to that top speed, I guess. Angular speed is it's the speed of how do I explain this? Okay, it's the maximum rotation speed in degrees per second. Stopping distance. Stopping distance is how fast the agent is gonna decelerate. Stopping distance is basically how fast how fast the agent is going to stop before it reaches to its destination or once it is within range of its destination. Auto traverse off mesh link. Okay, on Unity's website it says automate movement onto and off of off mesh links. I cannot explain this because I won't be using off-mesh links. I can't actually show you this thing working because I can't use off-mesh links. Auto repath. Acquire new path if existing path is partial or invalid. So for example, something like a blockage or it could be anything. The agent is going to take another path, whichever path seems best after this current path that it was going to take. It's going to redirect its way to that. Base offset. Unity's website says vertical offset of the collision geometry relative to the actual geometry. I don't know what that means. Obstacle avoidance type. The level of quality of avoidance. I actually forgot what this does. Sorry about that. NavMesh walkable specifies the types of NavMesh layers that the agent can traverse or walk on. For now I've selected everything, but I guess you can select other layers as well. Different characters might be able to walk on different layers. Now that our character has a NavMesh agent, we can set a destination for it and the character will go there. For that we need to create a script. Before creating the script, let's add an empty game object to the scene. We'll call this trigger. Where is it? There. Okay. Sorry, I said we'll call this trigger. No, we'll call this target. We're going to place the target here. And of course rename it to target. The name really doesn't matter. I just want to name it target. Okay, next we have to go to our character and create a script. We'll call this navigation script. Open this up in MonoDevelop. Okay, the first thing we need to create over here is a public game object and call this target as well. You can name it whatever you want. Next, we have to set the destination for our NavMesh agent. The way to do that is GameObject.getComponent NavMesh agent dot set destination, and within set destination it takes a single vector3 variable, so we can access our target's position. So that's target.transform.position, and we are done. What this is going to do is it's going to access the NavMesh agent component of our game object, and it's going to call the set destination method from that component, and then our character will go towards that destination. Before we can actually test this out, because we haven't specified what exactly our target is, yet we are using it over here. Let's just a minute. Sorry about that, guys. I had some technical issues, so let's pick up where I left off. Now, before we can run the game, we need to specify what our target is, because we haven't specified it in the script. Just a minute, let MonoDevelop open up. As you can see, we only created the variable. We have not actually specified which game object it is, and so that's why we need to drag our target over here, so that when the script accesses when the script tries to access target's position, it won't give an error because it is accessing our target's position over here. So now let's play the game. I'm going to keep this in scene view and not maximize it, so that you can actually see the capsule moving. As you can see, our character is automatically finding its way to our target. All we had to do was specify the location. Next, let's try a few things. We are going to use two really simple features, trigger and raycast with the navigation system. I will demonstrate these with separate examples. So for the first example, let's create a trigger for these lights, something that might switch off the lights. So I'm going to add an empty game object over here, and I'm going to add a box collider to it. And next I'm going to resize this box. Okay. Now let's add a script to this box. Before that, let me check this. Alright. Also, I have to add a player tag. You will see why. Okay. So let's first create a few empty game objects. Let's call it obj1, 2, 3, 4. I think there are 5 lights. Yeah. So let's create 5. Okay. Now, void on trigger enter and specify the parameter. Now as soon as something enters, or as soon as our player enters this trigger, we first want to check if whatever object has entered the trigger has the player tag or not. So that will be call.gameObject.tag. So if call.gameObject.tag equals player, then do whatever we are doing here. That will be obj1.light.enabled equals false. This is going to switch off the light. We'll do this for all 5 objects. Excuse the noise, it's my AC again. Okay, so apparently only when I create a second light trigger script, then this one works. There's something weird going on. I had saved the level and then I deleted some of the files, like some of the script files and all of the objects that were there, and I don't know, I did something wrong in between all that, and now this is happening, so just excuse that. Now let's drag all the lights that we want to switch off into our variables. Okay, I think we can run the game now. Let's see what happens. For this, I'm going to maximize. Okay, so our player is moving just fine. He's approaching the trigger. Didn't work. Okay, so what I forgot to do was add a rigid body, because in order for collision to take place or collision to be detected, either one of the objects should have a rigid body attached to them. I forgot about that, sorry. So now our script should work just fine. Let's play and see. It works. Okay, so we know that triggers work. Next, let's try using raycast. Now in the case of raycast, the best example I can give you right now would be creating an object and give it the object tag, and our player is moving according to whatever destination has been given. No, sorry, our character is moving according to whatever destination has been given and whatever calculations have been made for pathfinding. So we are not controlling the movement at all. Well, by ourselves we are not controlling the movement. Now what we want to see is whether or not raycasting will work while the player is navigating towards the target. So if our character does actually spot the object, then the character should stop. We'll add some code for that, but first let me create an object and place it in the right location. I think this location is fine. Let's create a tag called power up and assign that to our object. Now let's edit our navigation script. First of all, we need a raycast hit variable. Call this hit. Next, we need to use physics.raycast. Within that, we have to add all the information that is required by the method. So that's the position, the direction, that would be transform.forward, whatever it should, or whatever variable it should send the information to, and yeah, that's it. So the ray will be cast, and the moment it intersects a collider, we want to check if that that game object's tag is power up or not. If it is, then game object dot get component, basically this entire thing minus set destination. So game object dot get component NavMesh agent stop. Sorry, dropped my mouse. Okay. So if our our character spots this cube, then the character should stop. Let's see if this works. If it doesn't work, then I've probably placed it wrong, because the ray is being cast in a forward direction and I don't know if it's going to hit or not, but this is just to show you that raycast also works with navigation. Let's see. Okay, this did not work. Okay, sorry about that. I honestly have no idea what was wrong with Unity. For some reason it was using the old version of whatever scripts I had written, and it just became a huge mess. So yeah, I've fixed it now, and I've made one small change. I changed the location of the cube and I resized it, and now let's test out the raycast and see if it works. As you can see, the character has stopped. It's not going to go any further, although the target is, yeah, so although our target is over here, the player stops over here in this area and doesn't go up to there. Let's see what happens if I disable the cube. As you can see, the character has gone up to the target and not stopped uh, at the cube, because the cube is disabled right now. Oh, also I should have mentioned this earlier. I changed the tag just for testing purpose, but turns out I didn't really need to change it. But then yeah, I changed it. So yeah, just wanted to point that out. Okay, so this was the example on how raycasting works with the navigation system. I guess that's it. So this is how you use the navigation system in Unity. I hope this tutorial was helpful. Check out these other videos as well. The video on the top left teaches you about simple enemy AI. The video on the top right teaches you about raycasting, and the video on the bottom left teaches you how to use the interactive cloth. I'm also accepting donations, so if you would like to donate some money to support me, you can send it to my PayPal email ID, which is mentioned on the screen and in the description down below. Visit my channel for more videos. Don't forget to like, share and subscribe. Leave your comments below, and I'll see you guys next time. Boys, but we never seen him hang out on cover, now on album when he get the chance to hang. Like, damn, 1 3 4 niggas acting like I never been through them.